What I'm going to introduce to you now is called synthetic division. So hopefully you are all pretty comfortable with long division, polynomial division that you did in the previous lesson. And I'm going to change things up now, and I'm going to introduce you to this really cool sort of hack called synthetic division that's going to make dividing easier. I think that we can agree that polynomial division or polynomial long division works. It's timely. We trust it because we can see the process, which is really nice, and some of you are going to favor it. But what I'm asking is that you focus primarily on synthetic division. Part of the reason why I started with that lesson was to introduce you to some of the terminology like divisor and quotient that you're going to be seeing again today. Synthetic division is significantly faster, significantly. And as we head into this unit, you need to be capable of determining if something divides in really quickly, and long division, unfortunately, is going to betray you in the interest of time. So let's talk synthetic division. We're going to do it together as an example, and then I'll do a couple of quick ones, and hopefully you'll be able to pick it up, and just with a little bit of practice, you'll get there. So in order to use synthetic division, you must be using a polynomial as a divisor that takes the form x minus k. If you have any coefficient beside x, or if x has a degree higher than 1, you cannot use synthetic division, okay? No coefficients, degree of 1 has to, okay? So let's look at our first example here. I have divide x cubed minus 3x squared plus x plus 2 by x minus 2. I have confirmed x minus 2 matches this format, x minus k. What is k? That's going to be super important. So we're going to start by creating a chart. Create a chart of only the coefficients of the polynomial written in descending order of degree. So let's take a look. We're going to draw a chart that's like this big L. And across the top of the chart, we're going to write the coefficients of my question. So my first term has a coefficient of 1. And then negative 3x squared would be negative 3. X would be positive 1. And then 2, I'm just going to write the number 2. Perfect. On the left-hand side of this chart, I am going to write my k value. The k value is going to come from x minus 2. Recall that the format is x minus k, so k is going to be 2. It's inside the brackets there. So I'll write the 2 on the outside. Okay. That's your setup. That's it. I'm literally going to duplicate this, and we're going to continue on with the next step. Next step says bring down the first term. Okay? So I'm bringing down the first term. It's going to go underneath. This is the coefficient of the first term of the quotient. So we know our quotient, the first term, has a coefficient of 1. Then I need to multiply it by the k value and write the answer under the second term. Another way we say this is we say multiply across. So I take the 2, times it by 1, which is 2, and I'm going to add it right here. I'm using the arrows right now to show you the direction that we're working at, okay? 2 times 1 is going to go right there, okay? Next step, duplicate this. Here we go. We're now going to add vertically. Change colors. Another way of saying this is add down. So our first direction we multiplied across. I'm going to add down. Negative 3 plus 2 is negative 1. Okay. Next step. Now we're going to repeat the process, rinse and repeat, okay? I'm going to go multiply across. 2 times -1 is -2. And then I'm going to add down. 1 plus -2 is -1. Alrighty, here we go again. Well, I'm running out of colors. Pink. Multiply across. 2 times -1 is -2. Then I'm going to add down. In this case, is 0. This is a huge rainbow. I totally get it. There are 2 steps. Multiply across, add down. Now here's what this is telling us. I'm just going to shift it up for a little bit of space. First and foremost, this beautiful 0 at the end here, this is our remainder. We have a remainder of 0. Okay, that's super nice. I mean, you don't fully get it yet. When we start graphing, remainders of 0 are beautiful. And what these 3 numbers are our coefficients. That's not how you spell coefficients. Of the quotient. How do we write our quotient out? Well, let's do it properly. Let's actually write out our initial equation. Our initial equation was x to the 3 minus 3x squared plus x plus 2. And we broke that down. We said our divisor was x minus 2. And how do we get our answer now? We're literally just going to take 1 degree off of the first one. So it's going to be, we have x squared, then we'll have an x, and then this number will just be our whole number. And legit, all we're going to do is we're going to put the coefficients in front of them. My first coefficient is 1, I drop a 1 there. My next coefficient is -1, I drop a -1 there. My last whole number in this case is -1, drop a -1 there. So my answer is, or my quotient is x squared, take away x, take away 1, and I'll just write that down here. Clean it up, x squared, take away x, take away 1. You see how much quicker that is once you get the hang of it. Instead of doing long division, we can just almost jump right to the answer. Okay, let's do another one. Example number 2. First and foremost, we're checking, is x plus 1 in the right format? Absolutely. It's a degree 1. There's no coefficient on my x. Let's set this puppy up. I'm going to draw fewer steps this time so that things don't get wild messy. First off, I need to put my coefficients across the top. So I've got a 3x cubed, a 1 x squared, a -1 x, and then I've got a -6. My k value here is -1. It's going to be the opposite of this guy, of my 1. And now we go ahead. I drop down my 3, put it in the bottom. Multiply across. 3 times -1 is -3. Add down. 1 plus -3 is -2. Multiply across. -1 times -2 is 2. Add down. -1 plus 2 is 1. Multiply across. -1 times 1 is -1. Add down. -6 plus -1 is -7. -7 is our remainder. So we can write our final statement. Take our initial question, 3x cubed plus x squared minus x minus 6. I write my divisor, x plus 1. And now I'm going to write my quotient. I start off with a degree 1 less than the original question, and I grab my coefficients from down below. So I've got a 3x squared minus 2x plus 1, close bracket, and then I add my remainder, -7. Again, these coefficients match directly with the numbers at the bottom. All right, we're ready for a plot twist. I'm going to change things up a little bit. Here's how I'm going to change it. We have a problem here in our initial question. X minus 2 totally fits the bill. That's perfect. It's a degree of 1. It's got no coefficient. However, x cubed minus 2x minus 4 is missing some terms. Okay, we have an x squared term that is missing, and we cannot simply ignore the fact that it is missing. We need to have an x squared that is present, just like with long division. If it helps, you can rewrite this expression to include the 0x squared. My advice to you would be to do that until you are in such a habit that you just remember to do it on your own. Okay. Let's set it up. Let's do this weird L chart thing. I'm going to put my k out front for the first just because k is equal to 2. It's the opposite of the number in the bracket. All right, now I add my coefficients. I have a coefficient of 1 on my x cubed, 0 on the x squared, -2 on the x, and then I have a -4 at the end. And let's go. Change colors, why not? Bring the 1 down. Multiply across. 2 times 1 is 2. Add down. 0 plus 2 is 2. Multiply across. 2 times 2 is 4. Add down. -2 plus 4 is 2. Multiply across. 2 times 2 is 4. Add down. -4 plus 4 is 0. Yay, remainder of 0. Okay, let's write our final statement. We take our original question, I'll write my divisor, and then I'm going to write my final answer. I have a leading coefficient of 1, and that's going to be on an x squared. Remember, 1 degree lower than the initial question. So x squared plus 2x plus 2. Yay! No remainder on this one. Our last example here. I can take a look. I can see I'm not missing any terms. I've got a cubed, a squared, a degree of 1, and then a 0. However, we've got a problem. We cannot use synthetic division here. Why? Because there is a coefficient on the x. That's literally my last example. We're not actually going to do this. If you wanted to divide, you would use long division. That would be your only method here to go the long way, and you can go back a step if you would like. I'm telling you right now, it's not worth your time. There's a lot of fractions that get involved here. I purely included this example just to show you what it looks like when you're presented with a question and you cannot use synthetic division. Otherwise, if it hadn't have had that too, we absolutely would have been able to use it. Okay? All right, time to practice.